But now let's talk about electrical fields. Now, electrical fields are fields which are created by an electric charge. A point charge is a charge created by a single point, example a proton or an electron. The properties of the point charge are that it is radial, field is stronger, closer towards the point charge, it is made up of monopoles, and the arrows point away for a positive charge, or the arrows point inwards for a negative charge. The electric field strength is equal to kq divided by r squared, where E is the strength of the electric field, K is the Coulomb constant, Q is the charge of the point charge, and R is the distance from the charge. Oppositely charged particles create an attractive force for each other. Like charged particles create a repulsive force against each other. You do need to know to remember how to draw this. Now, the formula here is very similar to that of the gravitational potential energy. So instead of G, capital M, G, so instead of using this formula, we're using this formula. So it's actually very similar to one another, where in this case F stands for the force on the charge, K stands for the Coulomb constant, Q1 stands for charge of the first point charge, Q2 stands for the charge of the second point charge, and R is the distance between the centers of the two charges. Now, notice the diagrams. In the diagram, there is nothing in between the negative charges. The reason for that is because we said that field lines are vectors. Therefore, they would cancel each other out in the middle. Second of all, let's talk about kq1, q2 divided by r squared. In this case, we are referring to the fact that if we're looking at a proton and an electron revolves around a proton, right? So we can use this formula to find the electric force which is being applied on the electron by the proton, and obviously the force that the electron applies on the proton. Now, two oppositely charged plates create an electric field. And this is known as a dipole, indicated by the evenly spaced parallel lines. Putting a charged particle in the field will cause it to move towards the oppositely charged particle. Hence, work will be done on the particle. The field that you see here is different from a radial field, right? Therefore, we call this a uniform field. where the electric field strength is voltage divided by distance. Force is equal to Q multiplied by E, and work is charge multiplied by voltage. Where electric field strength is the strength of the external electric field, V is the voltage, D is the distance between the plates, F is the force in newtons, Q is the charge of the point charge, and W is the work in joules. So let's have a go at this question here. An electron is placed between two electric plates, which are placed 30 centimeters apart and have a potential difference of 20 volts. What is the force acting on the electron? Well, you know, voltage is 20 volts divided by a distance of 0.3. You can find the electric field strength. Let me write that again, that looks awful. The force acting here on the electron would be what we found here, 66.7 multiplied by 1.6 times 10 to the power of negative 19.